All right, everybody, we are live, and this is a very special CSN Planetarium astronomy Q&A, one of the ones that I've been looking forward to the very most because it's one of the questions that we get asked at the CSN Planetarium probably the most often, and that is the Pluto controversy. So Pluto, is it a planet? Is it not a planet? Why did things change? Did things change at all? Why do astronomers feel the need to bully Pluto all of the time? So those are the kinds of questions we're going to be getting into today. For those of you who don't remember me, my name is Nick Juliano. I am the CSN Planetarium Program Manager. I personally got my Bachelor of Science from SUNY Oneonta in the middle of upstate New York. I got that degree in physics. I came out to Las Vegas to do this job, and CSN is generously helping me get through my graduate studies at UNLV. And that brings us to our guest today. Our guest is David Rice. So David Rice is a PhD student in astronomy at UNLV. He researches the dynamics and compositions of planets around other stars. Although his focus is on exoplanets, he's always had a love for the cold but fascinating outer reaches of the solar system. So David actually has his bachelor degree, but he has two of them. He has one in physics and astronomy, and he has another in Earth and space science. So he's one of the most perfect people we could be having this discussion with today. But he just did recently get his Master of Science in Astronomy from UNLV. So congratulations for that. And thank you very much for being on with us today.
Thank you, Nick. Looking forward to talking with you. And I'm so happy the CSN Planetarium is in Las Vegas. You guys do such great work in educational outreach and informing people about astronomy.
Great.
Excited to be here.
Yeah, thank you very much for that. So you're currently studying for your PhD, right?
Yep.
And that is you're on my team with Dr. Stefan, who was on with us for the last live. Now your research is a little bit different from mine. So where mine is the detection of exoplanets, yours is in more so composition, correct?
Yeah, I do more theoretical work on the formation and the composition of exoplanets. So I don't think either of us identify as a planetary scientist. I think we both identify as astronomers. I've always had a love for Pluto. Definitely not a Pluto expert by any means. But a lot of the ideas I have come from like Phil Metzger in the University of California, Central Florida, and Alan Stern, who's the PI of New Horizons, and even Mike Brown, who's a Pluto killer from Caltech.
Yeah, we'll get into Mike Brown. He's probably a big topic of the conversation today. But yeah, that's awesome. So for our viewers, feel free to ask questions at any point during this. I'm going to be, if you catch me looking over here, I'm going to be monitoring the live stream so that I can make sure that we get to all of the questions. And we're not going to ask them we're not going to take kind of a chunk at the end to take the questions. We'll be answering questions as we go. So if I see them pop up, we'll take a look. We'll discuss that a little bit. But yeah, I do think you touched on something that was very important. The idea that both of us our research and our schooling and our education is mostly in astronomy proper. So there's a little bit of a difference between astronomy and planetary science, even though they sound like they're the same thing. There is a difference, and there are people whose sole kind of mission in life, their sole career is planets, studying planets specifically. So neither of us are those people. So a little bit of a caveat for that, right?
And we're gonna have a lot of fun discussing today about Pluto. But this was a big deal to a lot of scientists, and we try and keep our politics out of our science as much as we can. But of course, in these committees and these votes and things, there's tons of politics that go behind in the logistics of science.
Pretty much anything that has.
People got very mad about this. There's grudges to be had about this. We're kind of the next generation. We can have fun and talk about it.
Right.
There's still some emotion in this question.
Right. Like the war vets talking about wars they were in, and the kids who weren't there and don't quite have that experience and can look at it from a different angle. So that's kind of what we're dealing with right now. That's actually a good point. Yeah, so we're going to structure this live stream with three separate parts. The first one is going to be the definition of planets. So we'll talk a little bit about what makes a planet, if that's changed, how that's changed, and all of that. After that, David's been very generous enough to talk to us about what is it? The geology of Pluto. So kind of what makes Pluto so interesting. Why are people fanatics of Pluto? Even more so now that we know more about it. So that kind of stuff. And then we'll talk about classification as it applies to science, because that's kind of the heart of the argument, kind of the heart of the discussion for us for this. So, yeah. Anything I forget to add so far, David?
No, you're good. I'll put one more disclaimer that I'm okay with Pluto being called a dwarf planet. We'll get into the nitty gritty. I'm going to take the position of being Pluto a planet today. But there's, of course, nuance in there. And I hope I can get across that there are some problems with the way we've classified planets, even no matter how you come down to the end of it.
Yeah, there's always going to be kind of difficulties when it comes to that kind of stuff. Yeah, so I don't think either of us are too passionate on one side or the other, but we're taking different sides of the argument for the sake of an argument. And also, I kind of like going toe-to-toe with you. I think it's going to be a good time. All right, so let's get into part one. What makes a planet a planet? So the term planet actually does come from, it's one of the many things that we've inherited from past scientists. A few of them are very clunky, and a few of them aren't. The clunkiest example I can think of is the magnitude scale. How when you go higher in magnitude, it's a dimmer object, kind of the counterintuitiveness of that. But this term planet is actually something that we inherited. It comes from the ancient Greeks. I think the word is, and look in my notes, planon, Planan. And that word originally meant wanderer. Now, the reason we call planets wanderers is because when you look up in the sky on any given night, you can think of constellations. And those constellations don't actually appear to move. And what I mean by that is Orion's belt. Everybody knows Orion's belt, the famous asterism. It's 3 stars in a straight line. Now, those 3 stars don't move in relation to each other. They move across the sky, and they change positions throughout the year, but the relative position as it appears on any given night, those 3 stars will always be in a line. Planets were a little bit different. And when the ancient Greeks were studying the sky, when they were trying to figure out what was going on up there, they found these objects. And unlike the other stars, these fixed things in the sky, they appeared to move. So at one point, this bright dot would be in the region that Scorpius was in. And then at another time of the year or another century even, they would see it in a different location. So they would call them wanderers. And that has been passed down until today. So that's what we've been calling the things that we've identified that with. And originally they were only things, and correct me if I'm wrong, originally they were only things that we could actually see without a telescope. You could just see in the night sky, right?
Yeah, originally. Yeah. Sounds great.
So that was just, I believe it barely Mercury. You can only sometimes see Mercury, Venus, Mars, Jupiter, and Saturn. Those were the original planets because those were the only ones you can see without a telescope, just with your eyes. And then once we got telescopes, we started discovering other objects in our solar system, other objects orbiting the sun. And the big ones we would also call planets. So we added Uranus and Neptune to the list. And then in the early 1900s, they discovered Pluto. And that is kind of where the controversy begins, because we found Pluto. We attributed the name planet to this object, even though it was a little bit different from the others, but only in very slight ways. And then as time goes on, we start discovering more and more things in the solar system. We start discovering Charon, for example. Charon is what we now call a dwarf planet in the asteroid belt. Charon's Pluto's moon, correct?
Moon.
Yeah.
Ceres.
Ceres is the one I was thinking of. Yes, they've got similar spelling. Ceres is in the asteroid belt, and it's large enough to be considered a planet. Um, and then Charon, which shares an orbit with Pluto, the two kind of orbit common center of mass, center of gravity, and a few others. We started discovering all of these different things, and we were like, hey, are all of these things planets? Do we have to start adding more to the 9 planets that we've known for almost 100 years? Or do we have to reevaluate what we call things?
Mm-hmm.
And then that's where the International Astronomical Union comes in. Now, this is a group of astronomers, most notably, it's kind of a club. They're in general, the most respected people in their fields. You don't just get your PhD and join the IAU. There's a lot that goes into joining the IAU. You need to be very significant in the field. I think you even need to be nominated by someone who's already in the union. Is that correct? Do you know?
I don't know for sure.
That's one of my goals. So
society's work.
I'm going to have to look into that a bit. But yeah, so the IAU had a meeting in 2006 in Prague. And they wanted to delve into this controversy a bit more. Do we have 20 plus planets, or do we need to whittle down our list somewhat? And towards the end of that meeting, I think it was 2 weeks long. It was a 2-week-long meeting. They held a vote, and this vote was the 4th draft of the classification of a planet. And they made those 4 drafts, I believe, within that 2-week window. Things were added, taken away. It was this really complicated thing.
This last one was kind of secret too.
Right. Yeah, they snuck it in. This is where the politics come into play. And at the end of this really long conference, they held a vote on this 4th kind of amendment, 4th version of the Pluto, or the planet classification guidelines. And it passed. And it passed because there were 424 astronomers present for the vote. Now, that's less than 5% of the voting body of the IAU. Less than 5%. That's hardly even close to a quorum.
Everyone had gone home already. It was the last day of the conference.
Yeah, that's what I'm saying. I don't know about you, but I don't think my employer would be willing to dish out the cash for me to go to Prague for 2 weeks. Maybe 1 week. They've been generous with my travel so far, allowing me to go to conferences, but 2 weeks is a stretch, especially when it's international travel for most people. So a lot of people took the first week, or like a portion of it, and they went and they got what they came for, and they went home. And then the vote happened after most of them went home. 5% of the people voted, and it passed. So they decided to have a formal definition of a planet. Before that, there was nothing. Now there's a formal definition. And there's kind of 3 rules that go into making something officially a planet. It needs to fulfill all 3 of the check boxes. If it only fulfills 2, it's not a planet. If it only fulfills a different 2, it's not a planet. If it only fulfills one of them, not a planet. All 3. And they are, the first rule is that it orbits a star. That's an easy one. Pluto does orbit a star. The Earth orbits a star. The Jupiter orbits a star. All of these things orbit a star, the sun. But that's not narrow enough, because a lot of other things orbit the sun. We've got comets, we've got asteroids, we've got all of these different things. But Pluto does check off box number 1. Number 2, it needs to be large enough so that its gravity forces it into kind of mostly a spherical shape. So correct me if I'm wrong, is the Earth an oblate spheroid? It's oblate, right?
Yeah, partly because of the spin, that the equator is stretched out a little bit.
Right, yeah. So because of the Earth's rotation, it kind of causes the kind of middle of the Earth, I'm speaking in layman's terms here, to kind of belly out. So then the top kind of squishes down. So it's mostly a ball. If you look at it from space, it looks like a sphere. But it's kind of a hyper version of it is kind of like this. It's squished down a bit.
Yeah, as long as it's not a pile of like asteroids are rubble piles.
Right.
We see asteroids of all kinds of weird shapes. They're blobby things.
Yeah.
And actually, asteroids. A little more history. Asteroids were called planets up until like the 1950s. You can see asteroids being called planets.
Oh, really?
It wasn't until we like got pictures of them and we saw that their morphologies are different than planets. They're not circular. They're these big blobby things, rubble piles, that we decided that they should be a different classification. They should be asteroids.
Okay, so when we first started discovering things in the solar system that weren't the known planets, we also called them planets. So there have been
Kepler even called moons were secondary planets to Kepler.
Oh, really?
Kepler is one of the grandfathers of astronomy.
Yeah.
And he definitely grandfather of planetary science, and he would call moons secondary planets. So,
wow.
Yeah.
So in the 1950s, we had more than 9 planets?
Yeah, I've heard you can see papers where like the asteroids are called a moon or a planet passed by the Earth closely.
Oh, wow.
Yeah.
Huh. How about that? Oh, I didn't know that. That's awesome. Yeah, but the sphere shape is the second category there.
And Pluto is definitely a sphere shape.
Yes, Pluto does fit that category. So so far it has 2 out of 2. Let's add the third rule here. The third rule is that this is the actual wording here. It has cleared the neighborhood around its orbit. So in order for a planet to be considered a planet, it needs to fulfill this exact definition. It has cleared the neighborhood around its orbit.
Before we dig into that,
yeah,
let me give my view of history a little more. Is that even the asteroids were called planets until we saw they were different shapes, and then we started finding more and more bodies.
Mm-hmm.
And really, the nail in the coffin was Eris. Not Eros. Eros is in the asteroid belt. Eris is out in the Kuiper belt. And it was discovered by Mike Brown. That's why he's often called the Pluto killer, because he found Eris. And Eris is actually more massive than Pluto.
Okay,
Pluto has slightly a bigger radius than Eris, but Eris has a slightly bigger mass than Pluto. So in 2006, they were trying to name Eris. And this fight was a lot about naming rights. There was a process for naming planets that the discoverer gets to name it, where all these other bodies, these smaller bodies, there's a rigorous voting system to name them. So this whole thing, there's a lot of politics and stuff. We should get into the definition, but it came down to naming rights, and there was a lot of problems with how many people were there and the planetary scientists being left out of it. But yeah,
so
and it all comes down, right? It's just a duck test.
Does it? Pardon?
It's a duck test. Does it look like a duck? Does it swim like a duck? Does it quack like a duck?
And it's a duck.
A planet has to. We love groups of 3s as humans, so it had to look like a planet. It has to be spherical. It has to swim like a planet, which means it goes around the sun.
Mm-hmm.
And then we differ. We probably differ on what we agree means to quack like a planet.
Right.
So the IAU decided it was this dynamical definition of clearing its orbit.
Getting back to Eris, you said Mike Brown discovered that, correct?
Yeah.
With how Eris was lumped into a classification, was he able to name it?
No, it was named by the Minor Body Committee, I'm pretty sure.
Okay. And for some of our viewers who don't know this kind of a system, in the community of people who discover things in space, there are rules that determine how things are named. So you can't just discover an exoplanet, for example, and call it, like if I discover one, I can't just call it, oh, that's Planet Nick. There are schemes, there are systems, there are things in place that already determine what the name would be. And that even exists in our local solar system. For example, Saturn. We keep discovering moons of Saturn. And this one's actually pretty interesting too, because Saturn was a god in Roman mythology. I'm not entirely sure what the god what Saturn was the god of. But in the mythology, Saturn has a lot of lovers. So all of the moons of Saturn have to be named after lovers of the mythological god Saturn in mythology. But as they discover more and more moons, they're running out of Saturn's lovers. So they're going to have to figure out what's going on, because even this past year, I think we discovered like 10 or so.
Yeah.
A lot of new moons.
And Pluto's named after the god of the underworld.
Yes.
So all the moons, there's Styx and Hydra, and I'm blanking on the rest, but there's Styx and Hydra, these like underworld figures.
My favorite one is Charon. So for I'm sure we're the same age. We grew up on the Disney movie Hercules.
Mm-hmm.
In Hercules, Pluto would be Hades. They're the same person. But Charon, one of Pluto's largest moon, would be the ferry boat captain, pilot, rower, the person who operated the ferry boat to bring people to the underworld.
Yeah.
So that's who Charon is. I love that.
Interesting.
So, yeah. Okay. A little bit of a divergence.
Yeah. Go into the third. What
right.
Why
so this is where the controversy lies. This third definition, having cleared the neighborhood around its orbit, that's pretty vague. It's more open to interpretation than a lot of scientists are comfortable with. Even from day one that this passed, having cleared the neighborhood around its orbit is vague enough so that you can argue that most planets aren't planets. For example, Earth.
You're making my argument for me already?
I'm sorry. Are you on the...
tell us why Pluto didn't meet this criteria first.
Okay, Pluto didn't meet this criteria because it's in the Kuiper Belt. And the Kuiper Belt, in a nutshell, is a region of space away from the sun that has a ton of objects that are just like Pluto. So there was no possible verbiage to be found that would lump Pluto with the planets in the solar system, the 8 that we have now, but exclude the rest. So it was either Pluto has to be not considered a planet with all of these other things, or Pluto and these other things come in. It was one or the other. There was no just getting Pluto past the definition.
Mm-hmm.
So that's where the controversy is, right? And the interpretation of this third rule is that controversy, the clearing its neighborhood. My personal this isn't my opinion on Pluto or not, pro-Pluto or anti-Pluto, if you want to call it that. But my interpretation of that third rule is that it's too vague. If something hasn't cleared its neighborhood, or if something has cleared its neighborhood, that means it can be the only thing in that kind of a radius or a semi-major axis, that kind of area around the sun. The Earth has a moon. The moon is in the neighborhood of the Earth. The Earth has not cleared its neighborhood of anything, or of all things. It doesn't say how much it has to have cleared. It doesn't say what it has to have cleared. It's just that it needs to have cleared its neighborhood. There are more specific ways to talk about that.
In 2 weeks from now, there's a 2-mile asteroid passing within 4 million miles or something like that.
Right,
by the Earth.
Exactly, too.
4 million miles is not that far.
No.
A couple, like 10 times the distance of the moon. This asteroid, 2 miles wide, is passing the Earth.
Yeah. That's another thing. So the Earth hasn't cleared its neighborhood of asteroids either. So, and I'm pretty sure the same argument could be made for every single planet, even those that don't have moons, or the one that doesn't have the 2 that don't have moons. So that's kind of where things are. But the politics of this, do kind of center around this astronomer Mike Brown, who has for the past 14 years or so called himself the planet killer, or the Pluto killer. Pardon me. I think his Twitter handle is Pluto Killer, something like that. Yeah, he's very proud of the fact that he was the one to facilitate the demotion of Pluto, even though that also demoted a planet that he discovered, with that Eris. He wore that badge with pride, and he still does to this day. He calls himself the Pluto Killer, and he's very adamant about this. Now, this guy is a genius. I'm not knocking him in any way at all, but
now he's found Planet 9. So he has a new, that supposedly Planet 9 is a big planet way out there, which is an interesting, new studies are coming out on it all the time. But he was on that paper, so now he has his own planet, possibly.
Well, there you go. That's actually, I didn't hear about that. That's I'm gonna have to look into that. But yeah, so there are people who are facilitating this process. I'm sure in no small part to have their imprint on the history of astronomy. So once you get past the objectivity of things, the looking at things with no biases, and you just take a look at facts, that's when true science can happen. But it appears to be that the determination of these rules was not pure science. It wasn't objective. There was ego attached to it. Actually, I'm going to interrupt. Go ahead.
People have tried to make metrics now to understand this third rule of clearing the orbit. Mm-hmm. There has been several studies trying to make a metric of how far a body has to be tossed and how much amount of time for it to be clear. But there's a lot of problems with that. There's about 3 different metrics floating around. None of them have been adopted by the IAU, so there's no metric to determine what clearing the orbit means.
Right.
And the one thing I love to bring up is if you put Earth where Pluto is, Earth would no longer be a planet. So any definition that excludes the Earth from being a planet should probably not be the definition of a planet.
Well, it doesn't. The thing is, it doesn't exclude the Earth, because what you're talking about is a hypothetical. If you took the Earth and you put it somewhere else, you changed what the Earth is, it would be something different. Yes, that's obvious, because you're making an adjustment to something that is. So
because if we talk about, now I'm a dynamicist, so I love dynamics, and this should be my definition. But it's so weird to define a planet based on the gravity it has relative to other bodies. That means that this parameter, mathematically, if we go into mathematics here, it has to depend on how far that planet is away from the star.
Okay.
So you can't tell me that if you discover a planet someday with RV method and it's an Earth that's at 100 AU, you're not going to call it a planet. And then, and the really weird thing is a lot of these parameters also have to depend on the mass of the sun. So it determines, so this parameter of if it's a planet or not is determined by the mass of the star that it's around.
Right. But
because it has to be relative gravity.
If you have a huge chunk of rock just floating around in space and it's not orbiting something, I think that it's fair to call that not a planet. So in layman's terms, again, if you have a chunk of rock that's not orbiting something, it's not doing something that is planet-like. So I think having the definition dependent on the fact that it's orbiting something of whatever quality or caliber, I think that's fair.
But if you had a Mercury orbiting a smaller star and it crossed its threshold of not being a planet anymore because the star is smaller, you wouldn't want to call it a planet still?
You know, we're going to get back into this in the third part. I think we're getting a little bit too too in depth with that without completely surveying all of the other information. Yeah. That's a very good point. I'm going to reflect on that for.
There's one other thing people bring up in the third point also, is that about Neptune. Mm-hmm. and that we all saw when we grew up. We saw pictures of the solar system in 2 dimensions, and we saw that Pluto crosses Neptune's orbit.
Yes.
On these pictures.
Mm-hmm.
That's not really what happens in 3 dimensions.
Okay.
So Pluto is very elliptical compared to the other planets. The other planets have a circular orbit, while Pluto's orbit's more elongated. It's an ellipse.
It's like an oval.
And you would see pictures where Pluto's like this and Neptune's like this, and it crosses the orbit in 2 dimensions.
Yes, yeah.
But if you look in 3 dimensions, they're actually misaligned, and Pluto never actually crosses Neptune's orbit, the strict definition of what the orbit is.
It crosses the semi-major axis, the radius of that orbit, but it doesn't cross the orbit itself, because this is a 2-dimensional representation. We're on a screen right now. I don't really have the best way.
I got a picture.
Okay.
Real fast.
Yeah, let me pull it up.
Can you see that?
Yeah.
Yeah. So in 3 dimensions, here it still kind of looks like it crosses here. But this is actually outside of Neptune's orbit here, and inside of Neptune's orbit over here. And it never actually crosses the orbit of Neptune.
Okay.
And a fun fact is actually Pluto and Neptune never get within 8 astronomical units of each other.
Never. Okay. So for our viewers, an astronomical unit is the distance from the Earth to the sun. So what David's saying is that Pluto and Neptune never get within 8 times the distance of the Earth and the sun from each other.
Yeah. If you think about the Earth, Jupiter is always within 4 AU of the Earth. So the Earth is at 1 AU, just the distance from the sun to the Earth, and Jupiter is at 5. So Jupiter is almost always within 4 astronomical units between the Earth and Jupiter, while Pluto and Neptune never get within 8 astronomical units.
Wow.
So although Neptune is super important to shaping the Kuiper belt, it has very small effects on the Pluto's orbit.
Okay. Huh. Okay. That's interesting. Okay, let me see how I pull this back. Okay, we've got a couple things from our viewers. That's what I wanted to interrupt a while ago. Oh, Nicole Brooks, I was on the wrong live stream and missed so much. I'm sorry about that. The intro was pretty much just an intro. Now we're getting into the really gritty stuff. For Stephanie, I'm gonna say this wrong, Ishii, she actually has some pretty good insight on Saturn. Remember I said I don't know what god Saturn was? So Saturn was the Titan of time and was the lord of the universe until his children that he ate came out, led by Zeus, to destroy him. Okay, so Saturn wasn't actually a god. Saturn was a Titan.
Okay.
How about that? Okay. A little bit of weird stuff in there, but as I always say, the ancient Greeks were huge fans of wine and enjoying the nightlife, so they used their creativity quite a bit. That's awesome. Thank you very much for that input. All right, so let's get into the second part. Let's have your kind of, what did you call it, fandom of Pluto?
Oh yeah, this is my fanboying over Pluto. I've always loved Pluto so much. And Nick Juliano, my friend, wants to tell you that this body with soaring mountaintops, with seas of nitrogen ice, with floating water icebergs, with a blue sky and red snow, he wants to tell you this isn't a planet. This sounds like the perfect sci-fi planet to me. Many people call Pluto the second most geologically diverse planet after the Earth. So that's what, we can talk about classification more, but that's what I would prefer the third definition to be. I would rather stop at two criteria and stop after just being round. It should be a mass criteria and being round. It shouldn't depend on clearing the orbit. And it should be a geomorphology question. It should be, is it interesting geologically? Because that's what's important for planets. And Pluto's certainly interesting geologically. So here's our picture of Pluto. Just going to fanboy a little bit over Pluto. We've seen this picture when it was beamed back to the Earth by the New Horizons spacecraft with this heart shape on it that we've all seen memes of. This heart shape is called Sputnik Planitia, named after the first Russian probe to enter space. And we can look, you've seen the more colorful version too. That's false colors. Those colors are exaggerated here. But these were taken by the New Horizons spacecraft, which was launched to Pluto, the planet, in 2006, and flew by Pluto, the dwarf planet, in 2015, and beamed back these images. And New Horizons had some fantastic imaging equipment on it. Things we've never flown in space before that gave us amazing pictures. So if we zoom in on this Sputnik Planitia is this sea of nitrogen ice. These are glaciers that have flowed in to this deep depression on Pluto. And to show us the imaging equipment on here, we can zoom in and get in here in depth. And it's so interesting. You can see flows of the glaciers off the higher mountains. You can see these circulation cells, which are convection cells in the ice. And this whole area has no craters. There's not a single crater to be found on all of Sputnik Planitia, which tells us it's early. So we date. It's a very interesting technique. It's got a lot of assumptions that go into it, but we date planetary bodies by how many times it's been impacted by other things, how many craters there are on it. Something very new won't have time to be hit a lot, and something very old will have a ton of craters as it's hit by asteroids and things. So on Pluto, water ice makes mountains. The water ice is like the bedrock here on Earth. The water ice is so cold in Pluto, the surface gets to negative 380 degrees Fahrenheit out here at 40 AU. That these water ice mountains are brittle and form these huge mountains. They can be several miles high. And then the nitrogen ice it can create glaciers and flow into this. So it's a very complex. There's nitrogen ices, there's methane ices, there's water ices, there's ammonia ices, and all these ices are flowing together and combining together to create this geological cycle. That's all based on ice instead of rock. With New Horizons, you can zoom in even further, really see those mountains and glaciers. And here's a cut of the most high resolution photo of Pluto. This gets down to tens of meters in resolution. And you can see this glacier, the Sputnik Planitia, and these convection cells that we really don't understand yet.
So for perspective,
the water ice mountains.
For perspective, that would be tens of meters. So that's kind of the size of Badwater Basin in Death Valley.
Oh, I didn't put scale on here. You better not quote me on that.
Okay.
But yeah, this is really far in. This is
that's
very high detail.
That's kind of like, think of a satellite map zoomed in on parts of Death Valley. If that scaling is correct, that's really high resolution. That's awesome.
Yeah, and these little things are either water ice mountains. You can see them in this one too. That one's better. These are water ice mountains, either peeking through the glacier or that have broken off the mountains and are flowed down with the glacier. And water ice is actually less dense than the nitrogen ice. So these water ice mountains float along the glacier.
Wow.
Which is mind-boggling. And I mentioned Pluto has a blue atmosphere. You're going to call this not a planet. It's got a blue sky just like Earth. It's a little bit different process than the Earth that makes it blue. But we see this haze on an atmosphere. This is so unlike some of these other bodies that, like Ceres, doesn't have an atmosphere. So much more planetary. And we want to call it a planetary atmosphere, right? You don't want to call it a dwarf planetary atmosphere. You're not going to put that in a paper. So a lot of our terminology breaks down if we aren't careful with this terminology, with these classifications. And I have to talk about my favorite, I'll end soon, but my favorite is Tartarus Dorsa, which is down on this right side of Pluto. In Tartarus Dorsa, we didn't get great images of it. This is the best image. So this is very speculative, but there's some good evidence for it. These ridges can be a third of a mile high.
Oh, wow.
So these are deep ridges in the planet. And they often call it the snake skin. It's supposed to look like snake skin. And one of the leading, and they're all aligned. And interesting, they found a very high alignment between them, all north to south. And one of the leading theories about these are that they're penitentes, or penitents, which are actually a feature we get here on Earth. And this is in Chile, in dry, arid environments, very high up. The snow will sublimate. So we experience evaporation all the time on Earth, which is water is heated up and then turns into the gas form. On Pluto, because the atmosphere is so small and there's such little pressure, the ice, when it's exposed to the sun, can immediately go to the gas phase. So it's called sublimation when you go immediately from the gas phase or the solid phase to the gas phase.
Just a little anecdote for that. The band Sublime is named after the same process.
Yeah, that's cool. So these penitents are these ice ridges that get sublimated in this interesting way to form these ridges. And you can see some people in here. So on Earth, the penitents they can get up to like 5 meters high. So 5 times human height.
15 feet or so, 16, 17.
Yeah, the penitents on Pluto are 500 meters high.
Oh.
So a third of a mile high of these ice ridges. That's one of my favorite features on Pluto, for sure.
I apologize for the barking. That is my puppy who is not happy to be in his crate right now.
Oh,
That's
so
awesome.
Cute, though.
It was the Tartarus Dorsa. That's awesome.
Want me to fanboy more?
Yeah.
Yeah?
Definitely. No, I am not as familiar with Pluto as a geological body as you are, so I'm loving this lecture. I'm sure our audience is too. So please keep going for a bit.
You got to ask about this red region.
What's with the red region?
This false colors again. This is really what it looks like. But it's a redder region, this darker region. We call this the Cthulhu region, which is a favorite of a lot of people. And this red region is created by tholins. Oh, I can't say that word very well. Tholins. It's Tholins. And these are complex carbon molecules that are, when this nitrogen ice and this carbon monoxide ice and methane ice get into the atmosphere, they can then be hit by UV radiation from the sun. This is way far out there. There's not that much solar radiation out here, but that little radiation that happens out there can hit these atoms and create these tholins, these complex carbon molecules. And these actually scatter red light, so they're reddish, and it'll snow these tholins down on this area in red snow. And you can see in this region some mountains, and these mountains have peaks that are topped with methane ice. So this is a spectrograph image that highlights the methane. So just like Mount Charleston outside our window here has snow still at the top. I think it's still up there. I haven't checked recently. But the mountains on Pluto have ice caps that are usually methane ice that's bright white. So it's a really interesting region. They're still looking for cryovolcanoes. We see these fresh surfaces all over Pluto. So one of the best ways you get those fresh surfaces is by having a cryovolcano that spews out ices from the interior and snows down to make these fresh surfaces. There's some candidate cryovolcanoes that New Horizons saw. But once again, we flew by this rock like a speeding bullet. I forgot. I had an analogy on how fast it went by Pluto.
It's 8 miles a second. I was pretty sure it's 8 miles a second.
8 miles a second?
Yeah, I did the math once because they only give it in miles an hour. I converted it to miles a second. It's about 8 miles a second. So it would pass the Vegas Valley in all of 5 seconds or so.
Woo!
Yeah.
So see how many pictures you can take in 5 seconds over the Vegas Valley.
Yeah.
So we don't have that much information about Pluto. We've gotten so much from these pictures. There's still new papers coming out. There's tons of papers coming out about the interior of Pluto, what might be going on. All of this complex geology means there must be a liquid water ocean under the ice shell. You actually get these nitrogen ices subducting under the mountains, and complex geology just like we see on Earth. And how you get a tiny little body that no one wants to call a planet anymore, all the way out at 40 AU, that has enough heat to have a water ice ocean, is a super interesting problem in planetary science. And we're going to be finding out a lot more about in the future years.
All right, so that different type of screaming is my macaw. Some of you might have remembered Norman was a guest lecturer on our first live stream talking about life. And right now, Norman is apparently not happy with his life because he's also in his cage. I promise you both of them are well cared for. They are just a little grumpy right now because this is typically when we let them out. All right, but yeah, no, liquid ocean. Is the ocean, does it encase all of Pluto, kind of like some of the moons in our outer solar system, or do we think it's just an ocean rather than a fully encompassing body?
I think the consensus is leaning towards a global ocean right now. But that's the big question of a lot of these icy bodies. Are they regional oceans of water under the shell, or is it a global ocean under the shell?
Huh. Yeah. That would complicate things even further, I'd imagine.
For sure.
Anything else for us?
That's all about my fanboy.
All right.
I mean, I could go on for it. But that'll be good for today.
All right. That'll be good for today. We are getting a little bit longer here. Let me see how I can bring this back. Okay, here we are. Okay, so in the midst of you telling us all about all of these cool geological features, you got a little cheap shots in that I wasn't able to respond to. I appreciate that, though. That is a good tactic for debating. But I think that this whole conversation doesn't matter. And I need to elaborate on that because trying to find the words to elaborate on it. It doesn't matter what we call it. It doesn't matter if we changed Pluto's name to Bob, if we changed it to Teresa, if we changed it to Makemake, that's one of the other dwarf planets out there. It doesn't matter if we change what we call the thing specifically or what group we have it in. I think that all that matters is that we know about it. We use the information we get from Pluto to understand more about bodies in different regions of space that go through different things that might be able to even help us understand a bit about stuff going on here on Earth. So my argument is not, and it has never been, Pluto should not be considered a planet. My argument is that the definition right now is way too hazy to be something that is practically enforced, because you can't, if you apply the logic everywhere, there are very few planets in the entire universe. There would be a handful, if at best. But in the topic of Pluto, it doesn't matter. We have an appreciation for Pluto. We understand different things about Pluto. We're learning more. And whether or not it's a planet or not, it still has similarities and differences to other things, just like all planets have their similarities and their differences. So that kind of brings us into our last segment of this live stream, the classification. But before that, I do want to point out the New Horizons mission was where David got all of these photographs, all of these images before New Horizons went out to Pluto. Our only images of Pluto, so pre 2014 or so, our only images were pixels wide. It looked like a few squares. You ever play an 8-bit game, like a Nintendo game? Looks like we've got a guest lecturer.
Friend.
Hello, everybody. This is Bear. Bear likes to say hi. And he doesn't have any opinions on Pluto. He just has opinions on licking people. Let me get him out.
How did he get so big so fast?
Yeah, he is huge. Bear, come on.
Hey.
Bear, come on. Right.
Now, I would say there's 500 planets in the solar system.
You would?
Yeah, I would, at least over 100 different planets in the solar system.
Okay.
Would you have a problem with that? I
don't have a problem with anything. I think if you want to call them that, do that. That's the thing that I actually stress to this is refreshing because I typically have this conversation with a bunch of kindergarteners. And what I always tell them is something that I genuinely value. If you want to call Pluto a planet, feel free to do so, but just know that officially right now it's not considered. If you want to call those 200 objects that you're talking about, also I don't think I could name 200 objects in our solar system, unless we're talking about like people or objects in the solar system. But if you want to call all of these things planets, feel free. It's just clarify what you're talking about when you talking about it.
Definitely.
So
it's a scientific process. So I like to make the analogy with biology. That's the easiest analogy here, right? Is that when you teach kids about animals, you teach them the dog says bark. You don't teach them mammals say bark. You don't tell them that all fish you don't say all birds make the same noise. You teach them a chicken goes cluck and a mourning dove goes hoo, or a owl goes hoo.
Okay.
And you teach them about individual animals. You teach them how diverse and how expansive the animal kingdom is and life on this planet is. And then when it gets too big for their brains, because it gets too big for all of our brains eventually, then you start to classify. You can say, oh, these things are mammals and these things are bird. And it's a scientific process. We're taking a continuous spectrum. You have the platypus that has fur but lays egg, and we decided to put the line on the other side of the platypus from mammals to birds. So we're classifying these things to divide them up. And we've learned so much from doing that. It's a scientific process. We've learned, like evolution, that all the mammals came from one ancestor and all the birds came from one ancestor. So that kind of science comes afterwards. And it's the same thing in planets. We have this like unique opportunity today to re-examine our view of planets. We know of over 4,500 planets in other solar systems. And we can teach kids now about the diversity and the expansiveness, how much junk there is in the solar system, how many rocky bodies there are out there. And then we can divide it up. We can say these are the gas giants. We can even say these are the major planets and these are the minor planets. But we can say these are the gas giants. These are the terrestrial planets. These are the ice bodies. These are the ice giants. And that helps us with science. We do that in science because it's important, because I can't tell you how planets form. I have to divide it up. I can tell you how gas giants form and how terrestrial planets form. And it's a range of things that we're discretizing into different categories. So it's a super important scientific process how we're categorizing. So I definitely agree with you that It doesn't matter what you call it. It matters the scientific consensus. It doesn't matter a vote. The International Committee of like Biology, or whatever it's called, for biologists and not biologists by any means, they have a rule that taxonomy cannot be voted upon.
So how is it decided?
It's decided by scientific consensus,
Okay.
which is a long process of many papers and many careers before we reach a consensus on what a planet is.
Okay.
Yeah.
That is all very valid. And I only disagree with you on very slight things. But before we get to that, I want to see if there's any input from our viewers. One question: how was Pluto discovered? Do you know that? I know it was.
Yeah, Clyde Tombaugh. You got to go to Lowell Observatory in Flagstaff, Arizona. The story is amazing. Clyde Tombaugh was this little farmer who loved astronomy and wrote a letter to Lowell Observatory, and they hired him, and he drove all the way across the country. This little farmer from the Midwest, and discovered a planet.
Yeah,
fascinating story. You got to look into it.
Significant consequences for all of science too, as we're having this conversation to demonstrate. So just a farmer from Middle America, just was someone who discovered it. No formal education in astronomy, right? He taught himself, right?
Right. Yep.
Yeah.
And you take little slides of the sky. You take pictures of the sky every night, and then you flip between them, and you look for a light that moves. Mm-hmm. These wanderers.
Nowadays we automate that process, but early 1900s, like the 19-teens, I think, that was how it was discovered. Yeah, that's one of the most inspiring stories in astronomy that you don't. And this is something that I stress to people that visit the planetarium too. You don't need to study astronomy to practice astronomy. You don't need to have the formal education. It definitely helps. I wouldn't know as much as I do without the formal education, but if you have the passion for it, go at it. Like, nothing's stopping you. You don't need to have a license. Just go at it. It's problem solved. You're practicing the study of astronomy. So yeah, that's probably the best example of highlighting that. And I think that the Pluto discovery is remarkable too. So yeah. But to get back to your point about classification being important, yes, it is. But we've discovered all of these different objects in the solar system, in the local neighborhood of our galaxy, in our galactic cluster. And I think using the term planet as broadly as I think you're encouraging is, number one, publicly misleading. If we all of a sudden discover 200 or reclassify 200 planets or 200 celestial bodies as planets, the news would have a heyday, and people would be baffled by what happened. Conspiracy theories would run amok. And those kinds of things impact children in one way or another, who would grow up with these warped ideas of planets from all of these outlets where they hear about them. I think that would muddy the science. And just speaking in terms of a sociological consequences of that kind of a broad classification of using the term planets, I could see that going very wildly.
Yeah, it's really interesting because classification is definitely the scientific process that has very has a lot of power in science.
Yeah.
That's also the first thing that society interacts with, and education interacts with, and policies interact with. So we need science policy. We need people who study science, economics, and science policy to decide how these classifications interact with the public.
Right. I just think that there are better ways to I think keeping the term planet as a specific term to allot to objects that hold some sort of qualitative esteem, I'd say, keeps the importance, keeps the colossus of those objects intact. If I think your point saying like, oh, you've got a squirrel and a lion, those two things are different, but they're both mammals. Like going up to genus and familia biology stuff. Regrettably, I'm not too abreast to. I think that point is sound. I would just caution that we really need to be more broad, and we can't get into the minutia, because even now we're having this conversation and I'm rethinking everything I'm saying because you're making awesome arguments, but that's just muddying things. It doesn't, in the end, it doesn't matter when it comes to making these actual discoveries. Discovering Pluto's ocean is not contingent upon knowing that it's a planet or a dwarf planet. It's just contingent upon looking at it and wanting to know more.
Yeah, but because categories are the first thing that your senator is going to look at.
Okay.
They're going to look at, is it a planet? Like, should we go to Neptune, which is a planet? Neptune has a lot of cool things. We could learn a lot more about the ice giants. But come on, Pluto's geology is amazing. We got to go back to Pluto. We got to get an orbiter there to really dig into this geology of icy bodies. And your senator is going to interact with those categories, and for better or for worse. And it's interesting how that interaction is going to occur.
I'll give you that, and I think that that's good. But you're the coordinator. I think that's the title for Astronomy on Tap, correct? Mm-hmm. There was a recent picture posted on that Facebook page. Was it of Saturn or Jupiter? I think it was Jupiter, right?
Yeah.
Yeah. So there was it was an awesome picture of Jupiter. I don't have a better adjective for it. But we didn't have that picture 20 years ago. Mm-hmm. And I think the consequences of that picture, and being someone who doesn't know anything about atmospheric conditions of planets, being someone whose goal is to detect, not to further analyze, I think that those kinds of atmospheric fluctuations that were apparent were incredible. And I don't think we understand enough about those either. So there's also something to be said for the fact that everything in space is awesome and we should look at all of it. We've been to Pluto. We've been to Jupiter. We've just recently been to the Japanese sent something to, I think it was an asteroid. And they discovered that this asteroid was basically just a clump of gravel, is what it boiled down to. That's awesome too. While it doesn't quite have the geological activity, the fact that there's literally like a gravel mound floating around in space, it's very loose. It's not too structured. There's not much going on there. You could kind of punch through it, from my understanding. The fact that those things exist is awesome too. I think all of them are really cool. And if you're using the argument of classification as a way to have Pluto be studied, you could also make the argument of classification being the argument to study everything.
Yeah.
So,
yeah, if it's too broad, then the education could lack because it's too broad, and we could like decide not to visit anything anymore because it's like there's way too much out there to figure out. That's why we don't go to deep ocean a lot, is because there's just way too much out there to figure out.
Yeah, what part of the deep ocean do we go to? This part? That part? Oh.
So that's really interesting for sure. There's so much interesting planetary science going on. I know a lot of us are thinking about our lives here on Earth right now, but I definitely encourage the audience to reach out to your senators. There's so much to learn right now in planetary science. We're really on a new frontier of discovering stuff about our solar system. So yeah.
those people are remarkable. I think that's it's incredible stuff they do.
Follow us on Astronomy on Tap, Las Vegas. We do science outreach to adults mainly, but I post a ton of fun stuff on our Facebook page. So Facebook Astronomy on Tap, Las Vegas, for fun events and a lot of astronomy trivia.
Absolutely. I went to the last one. It was a great time. One final thing, because we're over the hour mark now, and I didn't feel like it. I'll tell you that. One final thing, a lot of people saying thank you, so interesting, learned a lot about Pluto. We're very appreciative for that. Thank you very much for all those comments. Nicole Brooks, once again, the one that is that Nicole, the one that missed
mythology
out? I'm not picking a side, but why can't we have 200 planets and still mainly acknowledge the well-known ones? Sure, it sounds can't read apparently. Sure, it sounds overwhelming in a way, but if only 8 are important, then only 8 are important. I can't see it as being harmful to school children or the media. The media is pretty whack anyway. That's a good point, but how my response to that personally is, how do you decide which ones are important or not? You need a classification.
You still need a metric.
Yeah, so you can call all of those objects planets if you want to, but at the same time, you're going to need something else to give the importance to the 8 objects that we're talking about. The 8 objects that are currently planets. If you make the term planet broad, you need a specific term for the other things. It's a tree. It's gonna keep spreading the more you generalize, because you're gonna need to have the specifics. So yeah, that is sound. But I think using the term planet, which already has a lot of emotional attachment for things, would wind up causing a bit of a stir. Again, personal opinion, I don't have any research or anything to back that up. It's just my interpretation of having interacted with the public in astrophysics for almost 10 years. So the classification still becomes a thing. In my opinion, I do think we're overclassifying, but there would be consequences. So
yeah. What's
your take?
That's so interesting. Yeah, you have so much experience with dealing with the public, so I bow to your knowledge.
I've spoken. I haven't done the math in a while, but I think it's well over 100,000 people that I've spoken to about space, and I'd say at least half of those have been about Pluto. So
it's crazy.
Yeah.
If you want to get into the third definition and the metric, there's the favorite metric. Oh shoot, I forget what's called. They call it lambda. There's a different version where you pretend the planet's at 1 AU. So you pretend the planet's at where Earth is, and then you calculate it. And then Pluto and Eris are both planets, and it still demotes some of the dwarf planets that are smaller and not interesting geologically.
Okay.
So
you said it's called lambda?
Next level stuff.
Do you know when that was published? I'd like to look that up.
I read the Wikipedia a couple days. That's the best place to find it. Look up the third definition of a planet clearing its orbit. There's a whole Wikipedia page on it and different metrics. I think it was by Alan Stern, the study. Alan Stern was on it, who's a PI of New Horizons.
Was he the one that retweeted you like a couple days ago?
No, it was a different astrobiologist.
Oh, that would have been awesome.
Yeah. Alan Stern has retweeted me before.
Put that on your CV.
If you want to follow at Magrathea Staff, Magrathea_staff on Twitter. I post a lot of astronomy stuff on there.
Absolutely. Anything else you want to add? I'm going to wrap this up now and make sure that my puppy is okay, and maybe have a conversation with him about Pluto. Anything else for us? Any other plugs you want to plug in?
No, that's great. If you want to email me, it's david.rice@unlv.edu. Just my name, David Rice @unlv.edu. Follow us on Astronomy on Tap. And it was great talking to you, Nick.
One more question. I'm sorry, this one just popped up. Rachel says, do you think we will discover any new planets in the Kuiper Belt?
In the Kuiper Belt?
Mm-hmm.
Depends on your definition of Kuiper Belt. I think we're out past the Kuiper Belt for a body that big yet. it's in the scattered disk. So some people would call the scattered disk still the Kuiper belt. You could call it the Kuiper belt still, but if bodies past the Kuiper belt, that's called the scattered disk, and that's where Sedna is. Sedna is another very big body out there that's a minor planet, and there still is a lot of room out there to find another planet. Yeah, I could do a whole another one of these on Planet 9. It's a really interesting study coming out.
And then we actually had another one pop up. This is awesome. So Nicole says, what do we call other bodies floating out there? There's
floating out there. Rogue planets?
Yeah, I think she's just talking about how do we classify other things? So yeah, there are rogue planets, or I think we call them orphaned planets too. Those are planets or kind of planet-sized objects, and this one hasn't. I don't believe this one's been formalized, this definition, but kind of planet-sized objects that aren't orbiting a star because of one reason or another. The reason typically is that they interacted gravitationally with another object while they were in some sort of stellar system in kind of like a planet status, and that ejected them from their orbit, and they're just flying willy-nilly out in space. Those are tough to find because they don't really interact with many things, and they're far away from any light source. So you can't see them, and you can't detect them by how they're doing things to other stuff. We also have moons.
We're in the heyday of taxonomy for planets, right? Like it's a big problem in exoplanets right now is terminology about these exoplanets, planets around other stars. We have sub-Neptune planets, we have super-Earth planets, we have Earth-like planets, we have Venus-like planets, we have hot Jupiters, we have warm Jupiters, we have cold Jupiters, we have super puffs. And
did you say super puffs?
Yeah, super puffs are a lot of fun.
What is a super puff?
It's like a Saturn that's super close to the sun, so it heats up and its atmosphere is gigantic, so its density is like 1 gram per centimeter cubed. Wow. So it's like super, like it would float in water.
Yeah.
It's like
super
very
puffs. That's awesome.
Less dense planets. It's a big problem right now, but that's why I was talking about. It takes scientific consensus. It's not a pretty process. It's a long process that we have to go through to figure out how we're going to classify all of these things.
Right. Yeah. So, yeah, how do we classify other things? We're still figuring that out, but the general things you've heard of, asteroid, moon, you might have heard of exoplanet, planet, star. Those are all different ways we classify objects out in space. And then this one's not a question. It's from Keith over in LVAS, the Las Vegas Astronomical Society. They're a group of informal astronomers. I've spoken about them in past live streams. Do really great stuff. I always yield to them when it comes to night sky observing because they've got the equipment, they've got the know-how, and they're really great. So Keith says, when we show the public planets in our telescopes, we inevitably get questions on why Pluto got demoted. People in general are sad about it. Personally, I'm a bit sad about it too, since New Horizons went there and showed Pluto was more awesome than I could have personally or could have possibly imagined. So it sounds like, Keith, you and David have a lot in common.
It's awesome.
Yeah. Awesome.
There's so many great science opportunities in Las Vegas right now.
Yeah.
There's Planetarium and Astronomical Society and stuff happening at UNLV. Yeah.
Yeah, astronomy on tap as well. All right, I'm going to wrap this up, David. Thank you so much for your time. I took up quite a bit of your time. I don't even have a clock on me right now, but thank you so much for your knowledge.
I'm just at my house all day, every day.
I'm going to go walk. When all of this is over, I'm going to go walk around and tell everybody about Super Puffs. So great. All right. So that wraps up this one. If you have any suggestions on things we can live stream, maybe I could even ask David to be back in this because it seems like everybody loves him. Let's leave them in the comments. Thank you very much for all of your questions. We will continue this in the future. Great. So that is the Pluto controversy in a nutshell, and the conversation's still going on. All right. So thank you very much. Once again, David, thank you very much too.
You bet. Thank you.
All right.